Next, we're ready to look at the graph of secant. And as is our custom, we'll go back to the unit circle and recognize the relationship that secant is equal to 1 over cosine theta. So understanding this relationship together with what we know about the unit circle will help us to get an idea about what the graph of secant must look like. Now, a couple of things we want to notice first of all. Cosine is equal to 0 at pi over 2 and 3 pi over 2, all coterminal angles to those. Well, that tells us that secant, of course, is undefined there. So secant theta is undefined at pi over 2 and any integer multiple of pi added to pi over 2. So at pi over 2, 3 pi over 2, and on around, all the coterminal angles, that's where we have secant undefined. So we want to keep that in mind. Now something else we want to notice, and that is, at 0 and 2 pi, cosine is equal to 1. Well, that means that secant is equal to 1 there as well. So at 0, at 2 pi, at 4 pi, all the coterminal angles, secant is equal to 1. Likewise, at pi and all its coterminal angles, cosine is equal to negative 1. Therefore, secant theta is equal to negative 1. Okay, so now we want to take that little bit of information and see if we can put together what the graph must look like. So what I've got here is I've got a little grid, and I've made the horizontal scale to be pi over 2. Okay, so we go 0 to pi over 2 to pi, 3 pi over 2, and so forth. And I want to, first of all, just take note, I want to put the graph of cosine. Remember, secant is 1 over cosine. So I'm putting the graph of cosine here, and this will help us to understand even more what the graph of secant is going to look like. Now, notice at every place the cosine crosses the x-axis, that corresponds to an asymptote, a vertical asymptote. So I'm just going to go ahead and put the asymptote there. That's where secant is undefined. And that's where we have a vertical asymptote. And we'll be able to see in a minute why it's a vertical asymptote. Now, you'll also notice this, that at negative pi, notice cosine is negative 1. At 0, cosine is 1. And at pi, cosine is negative 1. So we start to see what's going to happen with this graph. Now remember, secant can never equal 0 because it's 1 over cosine. There's nothing that you can divide into 1 and get 0. So we know for sure that secant can never be 0. So it's never going to cross the x-axis. So this helps us to start to see, well, what's going to happen to this graph. Remember, cosecant is going to be asymptotic to the asymptotes. It's going to be, for example, right here in the middle, it's going to have a value of 1, but it's never going to cross this axis down here. It's going to be asymptotic to these asymptotes. And notice, as cosine gets closer and closer to 0, the 1 on the top stays constant. So what we have is a situation where you have 1 being divided by an increasingly smaller number. So notice here we have a constant of a 1 up top, 1 over cosine. As cosine diminishes, as it gets smaller and smaller, we notice that secant would increase without bounds. Okay? So let's see if we can figure out what the graph looks like. Now, we're going to have the graph touching at these dots that I've just placed on the graph. Now let's look at the graph. There's what the graph would look like. Because notice, it comes down to a minimum point, is asymptotic at the asymptotes. Over here, it comes to the high point here, which is at negative 1, then it's asymptotic along the asymptotes. Same thing over here between pi over 2 and 3 pi over 2. So this is the graph of secant. Now just some things we want to observe. The domain, theta cannot be equal to pi over 2 or pi over 2 having any multiple of pi added to it. Now that's an integer multiple of pi. Okay. So theta does not equal pi over 2 plus k pi. And you can see that from the graph. Definitely those values where we have asymptotes are not part of the domain. Now the period, of course, is going to be 2 pi, just like with cosine. It's going to be 2 pi. You can see that the time it takes for the graph to make one complete cycle. We have the little graph, part of the graph here, and then up here, the time it takes for that to happen is 2 pi. Starts over here at negative 3 pi over 2 and goes to 2 pi. So that would be, or pi over 2, so that would be 2 pi. The range we're going to have we see the graph goes from negative infinity to negative 1, inclusive of negative 1. Then it skips this area in here. And then it goes from 1 to infinity. So that is the range of secant.